Scene script. Have you ever gazed at the night sky and wondered about the vast, unending expanse of the cosmos? Let's take a moment to unravel this cosmic enigma. When we talk about space, we're referring to the boundless three-dimensional extent in which objects and events occur and have relative position and direction. It's a concept that's as intriguing as it is complex. Space isn't just an empty void, it's a realm filled with almost nothing. This almost nothing is actually a hard vacuum, a state of matter with no atoms, which contains a low density of particles. These particles are so few and far between that for all intents and purposes, space appears empty. But it's not. Within this seemingly empty expanse, there's more than meets the eye. Galaxies, stars, and planets exist within this space, each with their own unique characteristics and stories. They're scattered across the cosmos, distant and yet connected, each playing their part in the grand theater of the universe. Consider the countless galaxies that make up the universe. Each one is a sprawling metropolis of stars, each star potentially hosting planets. And perhaps on some of those planets, life as we know it, or as we can't even begin to comprehend, exists. Then there are the celestial bodies closer to home. Our very own star, the Sun, around which our life-sustaining planet orbits, is also a part of this cosmic tableau. It's a constant reminder of our place in the universe, a tiny speck in a vast cosmic ocean. Yet, despite our seemingly insignificant size, we've managed to make a substantial impact. We've sent explorers to the moon, rovers to Mars, and probes beyond the confines of our solar system. And perhaps most importantly, we've launched satellites, our eyes and ears in the sky, into orbit. And in this vast expanse, we have managed to make our mark by sending satellites into orbit. As we venture further into the cosmos, who knows what other marks we'll leave and what other secrets we'll uncover. Ever imagined a world without satellites? It might be harder than you think. Let's consider a day in your life. You wake up, check your weather app to plan your outfit, turn on your television for the morning news, and drive to work using your GPS. These tasks, which have become second nature to us, all rely on satellites orbiting our planet. Satellites play an indispensable role in our everyday lives. They are the invisible workhorses that help us predict weather patterns, making it possible for us to prepare for storms or enjoy sunny days. They serve as the backbone of television and radio transmission, providing us with entertainment and important news updates. But the utility of satellites extends far beyond these everyday conveniences. They are the silent sentinels in the sky, safeguarding us through GPS navigation. This technology ensures that aircraft, ships, and even our cars stay on the right path, preventing accidents and saving lives. Satellites are also the unsung heroes of scientific research. They allow us to study our planet and the universe beyond in ways that would be impossible from the ground. They help scientists monitor climate change, observe distant galaxies, and even search for extraterrestrial life. Moreover, satellites have revolutionized communication and information gathering. They have made it possible for us to connect with people across the globe instantly, breaking down geographical barriers and fostering global unity. They enable us to access vast amounts of information at our fingertips, expanding our knowledge and understanding of the world. Think about the last time you used your smartphone to video call a friend living halfway across the world, or when you used an online map to find your way in a new city. All of these conveniences are made possible by the network of satellites orbiting high above us. So the next time you check the weather, turn on your TV, or use your GPS, remember the silent heroes working tirelessly in the outer realms of our atmosphere. They are the tireless workhorses that make our modern world function smoothly. Indeed, satellites are the silent heroes of our modern world, working tirelessly from the outer realms of our atmosphere. How do these metal marvels stay up there, you ask? Let's delve into the physics of it. The first step in the life of a satellite is its launch. Rockets, which are essentially powerful vehicles, are used to propel satellites beyond the Earth's atmosphere. Once the rocket reaches a certain altitude, it releases the satellite. However, the journey doesn't end there. The satellite must reach a certain speed to stay in orbit. This is where the concept of gravity comes into play. Imagine throwing a ball. The ball will travel in a curved path and eventually fall to the ground due to gravity. Now, imagine throwing it harder. The ball will travel further before it falls. If you throw it hard enough, the ball will fall around the Earth instead of falling back to it. This is essentially what an orbit is, a constant fall towards Earth. Now that we've got the basics covered, let's talk about the different types of orbits. The first one is the geostationary orbit. Satellites in this orbit move at the same rotational speed as the Earth, making them appear stationary from a point on the Earth's surface. This is particularly useful for weather monitoring and communication satellites, as they can continuously cover the same area. The second type is the polar orbit. Satellites in this orbit travel from the North to the South Pole and back, passing over all areas of the Earth. This is great for mapping and surveillance satellites, as they can capture every part of the Earth as it rotates underneath. But it doesn't stop there. There are many other orbits, each with their own unique characteristics and uses. From low Earth orbits perfect for the International Space Station, to highly elliptical orbits that bring satellites closer and then further away from Earth. Each has its purpose in our quest to explore and understand our universe. So now we've unraveled the secret of how satellites remain in the sky, ensuring our world runs smoothly. So let's recap what we've learned about the cosmic ballet and its metal dancers. Our journey began with a dive into the mysteries of the cosmos. We learned that space is not just an empty void, but a vast expanse teeming with galaxies, stars, and planets. This grand stage is so vast that it boggles the mind. From the tiniest specks of dust to the largest superclusters of galaxies, everything we know exists in this infinite expanse. It's a realm of extremes, where temperatures can range from unimaginably hot to absolute zero, and where silence dominates, broken only by the occasional cosmic event. Next, we delved into the world of satellites, the marvels of modern technology that tirelessly orbit our Earth. These unassuming metal contraptions, small enough to fit in your backyard, have revolutionized our lives in ways we often take for granted. They're our eyes in the sky, helping us predict weather patterns, monitor climate change, and track natural disasters. They keep us connected, enabling global communication and navigation, and they push the boundaries of our knowledge, exploring distant planets and far-off galaxies. But it's not just about what satellites do, it's also about how they do it. We dived into the mechanics of satellites, understanding how they stay in orbit, resist Earth's gravitational pull, and communicate with our ground stations. It's a dance of precision and balance, a testament to human ingenuity and our quest to conquer the unknown. So as we wrap up our cosmic journey, let's appreciate the intricate ballet that unfolds above us each day. Space, a vast and mysterious expanse, and satellites, our silent heroes, play a crucial role in shaping our daily lives, from the mundane to the extraordinary. They're a testament to our curiosity, our ingenuity, and our unending quest to understand the universe we inhabit. The next time you look up at the night sky, remember the vast expanse of space and the silent heroes, the satellites, that make our modern life possible.